démarrer le live, mais je mets une vidéo en fait, comme ça à 9h.
Hello, everyone. Good morning, good afternoon, good evening. My name is Florent. I am from Paris, France. And Happy New Year, because this is actually the first live stream of the year for me. Last year, in December, I started a live stream about GoGM, which is a Node.jm for Neo4j in Golang, with Eric Solander, the maintainer and founder of Mindstand, is the CTO of Mindstand, and we'll resume that series hopefully later this month. But in the interim, I was thinking of doing maybe a short introduction to Liquibase and Liquigraph, actually. I keep mixing up the names. But yeah, I'm gonna try today to show you what Liquigraph can do and how it can help, with the database refactoring automation. But before I start, I just want to make sure that first you can hear me well and see my screen. So if you can confirm in the comments about the setup that we hear everything, I just checked before, but we never know. Sometimes there are some setup issues. Hopefully it's not the case today. And I would love to hear where you're from as well, so that can give me an idea of what the audience is today. So I'm checking the chat on the side, which is where you can see me turn my head from time to time. Okay, great. And we have some people from Germany, so willkommen. Ich bin sehr froh, Sie hier sind. And that's about it. My German is so rusty. And from the UK as well, so welcome here and good morning. So let's talk about database refactoring in general. So refactoring, when we hear this term, we usually think about application development, right? That's a common practice to try to improve the internals of an application or of a section of an application without changing its observable behavior. That's in the kind of the idea of continuous improvement, so that the application doesn't rot and is easier to maintain over time. But for a long time, at least, there used to be, with the rise of agility, there used to be some kind of friction, between the database teams maybe and the application teams, where agility, pushed teams to try to ship more often, every 2 weeks, every week, every month, but not every 6 months or every year. And there used to be, not everywhere, of course, but there used to be some friction. And it happened to me also, a couple of times in my previous experiences. And in 2006, there was a book that became quite influential called Refactoring Databases, which is basically a catalog of various techniques to improve the internals of to improve the structures, to refactor the structures, to give you some techniques to be able to do that and be able to follow the flow of, rapid iterations. And this book was so influential that it gave birth, it influenced many software developers around the world, including Nathan Voxland, who is the creator of Liquibase. And as I mentioned earlier, I mixed up the names. Liquibase, so I'm not going to talk about Liquibase today, so I might talk about it soon, but Liquibase, just real quick, I'm not going to show how it works today. I'm going to focus on Liquigraph, which is a different project, but Liquibase, and oh, we have someone from Australia. Hey, welcome here. So happy to see you all. And I was saying, yeah, Liquibase is a database refactoring automation tool, but usually tailored for relational databases. So if you check their websites on liquibase.com, you will see they support many, many databases, and a vast majority of them are relational databases. That doesn't mean it cannot work with NoSQL databases. Oh, and hello from Serbia. Nice. Yeah, quite an international crowd today. I'm happy to see that. And so Liquibase is mostly tailored for relational databases. Also, it's less and less true. They support some other NoSQL databases. And actually, I will have a small announcement to make towards the end of the live stream about that. But yeah, so that's where Liquigraph, which is my own project I started years ago, as a hobby project mostly, took its inspiration from. So that's why the names are quite similar, and sometimes people can mix it up, even myself, because I just did like 3 minutes ago. And so Liquigraph is more or less a subset, in a way, or at least a resembling subset of the features of Liquibase. So I am very, very aware that the current documentation, the current website is ugly. I'm actually working on making it a bit better. So that's a work in progress. Hopefully a new documentation will be published soon, more streamlined with the important information bits that come first. As I was telling you, this used to be a hobby project. I joined Neo4j quite recently, and before that, I didn't have much bandwidth to work on it. So that's why I really insist on saying Liquigraph is a subset of Liquibase. Liquibase, is I believe has more than 15 years, so it's been quite battle tested. The feature set is quite impressive. Liquigraph, in comparison, it's quite small and only implemented the basic functionalities of Liquibase. And yeah, so that's just the introduction. Talking about database refactoring, which is not an association of words we hear very often, and what tools there are in this space. So in the case of Neo4j, there are also other ways. Before I start diving into Liquigraph, I also want to mention other projects, because that's not the only one. That's probably one of the oldest ones doing that, but not the only one. My colleague, for instance, Michael Simons, who is in the Spring Data Neo4j team, created another project. So if we Google Michael Simons migrations, I think we will find it quite easily. Yeah, that's called Neo4j migrations. And it's funny because Liquigraph, is inspired from the project Liquibase. And I believe, I think I'm not wrong in saying that Neo4j migration is inspired, and it's actually written in the README, is inspired by FlyWayDB, which is another tool, available in the toolkit for developers. And you will see indeed that they have two different perspectives on running migrations. They have, between Flyway and Liquibase. So it's quite funny that both I and Michael became inspired by these two projects. So that's quite a complementary approach. So pick the one you like, pick the one that suits best your philosophy of organizing database migrations. And maybe some other tool, maybe not are as their main feature, also include database migration. I mentioned GoGM, so the OGM for Golang. So we started a live stream series about that last month with Eric Solander, CTO of Mindstand and maintainer of GoGM. And it just happens that GoGM also has some database schema features. So when you model your entities, you can also say, oh, this field is indexed, this field is unique, etc., etc. So in a way, it helps you manage in some kind of ways the database state as well. So you could see that as a lightweight database management tool. And the funny bit is GoGM actually was inspired by Neo4j OGM, which used to be the library underneath Spring Data Neo4j. So Spring Data Neo4j 6 today is the latest major version of Spring Data Neo4j. It doesn't use OGM anymore. But Spring Data Neo4j 5 was built upon Neo4j OGM, and you had also this capability of annotating your class fields, saying this one is unique, this one is must be indexed, etc., etc. So that's why you can see the connection. Connections are everywhere, I would say, and that's still a proof today. So yeah, GoGM, inspired by Neo4j OGM in the Java world, also allows you to index fields, etc. And so why my colleague Michael started working on a migration tool, by the way, is because and so yeah, sorry. So I'm back. So the funny bit is because Spring Data Neo4j 6 decided to get a narrower focus, more focus on what an OGM, an object graph mapping tool should do, and they decided that creating indices, etc., is not the job of an object graph mapping tool. That's why that's basically got descoped of Spring Data Neo4j 6. And Michael Simon, that's the motivation for creating a standalone tool for that. And that's why we have also today this Neo4j migration tool by Michael. So that's about the alternatives I know. I think some other projects. So I mentioned Golang. Golang with GoGM. Mentioned Java with Spring Data Neo4j 5 or Neo4j OGM. I believe I've seen some recent TypeScript projects also in trying to do some object graph mapping with this kind of unique or indexed field annotations. So that I think you have similar options whatever the ecosystem you're developing in. And so now let's switch to actually see what Liquigraph is about. So let's close all this. And let's start with a very simple demo. So I have a database on my right. And let me know if you can see it well. If not, I will try to zoom in a little bit. So hopefully it should be empty. If not, we'll make sure. Oh, it's not empty, of course. So let's first start with an empty database. We don't have to, but and detach delete, of course, because I cannot delete nodes if I don't delete the relationships before. All right, okay, so now we have a blank slate. It's not necessary, but it makes the demo probably a bit easier to understand. And one thing you need to know, so if you're familiar with Liquibase, so the migration tool, very popular in the Java JVM ecosystem, you have several formats. In the case of Liquigraph, because it's a subset, and mostly used to be a hobby project until now, you only XML is supported because it's easier to parse. There are nice libraries in the Java world because Liquigraph is written in Java, but only XML is available at the moment. And so the first notion to understand is when you want to execute Liquigraph, you needed to give it a single entry point. And that entry point is called a changelog file. A changelog is what? It's a sequence of migrations. So you always have a single entry point. So let's have a look. I have here, and I'm gonna probably maximize this for a while. I have a very simple changelog, which is a changelog node. And in that case, I could define migrations directly here, but I wanted to show you another way of organizing your files, and that's why I'm using the import. But basically, if you import or if you write your migrations directly here, or if you mix both, that works as well. What's going to happen? It's going to be processed, pre-processed, and the contents of the XML file referenced here will be injected into the main document. So in the end, it doesn't really matter. It's mostly for readability purposes. And one pattern that is quite common is to have what I call a master changelog, so the single entry points that the Liquigraph executable needs. And then per version of your application or your database, have a folder, and that folder. So in that case, I have a simple demo for now. I have a master changelog per version, and that's what I do here. So the master changelog will import the master changelogs. Oh, you don't see my screen, right? Oops, indeed. So sorry about that. Thank you for the comment, Mishinef on Twitch. Indeed, because I lost my connection for a few seconds, and then my screen sharing was disabled. So yes, I thought I was showing actually some stuff, but no. So as I was saying, there is a single entry point called changelog. Changelog is a series of migration, but in that case, I'm not defining all the migration in a single file. I'm using the import. So hopefully you can see that a bit more. Yeah, so hopefully it should be readable now. Thank you again for the comments, because I could have I could have gone the full hour without realizing it. And so here what I'm showing is a pattern of when I have a folder per version. So I have a single master changelog, that's the one that I will give to the Liquigraph executable. And in each version folder, in that case I have only one folder, I have a master changelog as well. And that way my master changelog will import each master changelog of the version folder. And then my master changelog for the version will include the migration files. So, I mean, if you only have a couple of migrations, it's probably not worth, organizing it like that. But, usually migrations tend to grow in number. So it's usually better to organize it that way, so you're not lost in the in the jungle of migrations afterwards. And so far we have not seen much. We have seen changelogs that can import other changelogs relative to their current location. And yeah, but okay, what does a migration look like? That's what we are here for. So let's look at init-domain.xml. And init domain looks the same in the envelope. It's still a changelog node as a root node. And we have change sets. Okay, that's new. We have not seen that so far. And what's a change set? Change set is a migration. It is a migration. And what does it? And it means also something very important about change sets. They run in their own transactions. And I will come back to that a little bit. Which means that if a change set fails, doesn't mean the previous change set won't be persisted. No, all the previous change sets. So let's say in that case, let's say my second change set here fails. Well, it's a separate transaction. So if the first one succeeds, it will be remembered as such. The query that is defined will be executed, etc., etc. So they are independent, run in separate transactions. And one very important thing to know with change sets, so they can run one-to-many cipher queries and any cipher queries. So you could, of course, define read-only queries, but that would not be very interesting for a migration tool. But for instance, you could define indices, you could define constraints on your database. But Neo4j does not allow mixing schema / constraint / index operations with data operations like create, merge, etc. within the same transaction. So as a corollary, you cannot mix data and schema operations within the same change set, because again, the mental model is a change set is one transaction. It's a separate transaction. So that's why you cannot mix it. If you need to create schema, constraints, etc., create them in their own change sets, and then create the data. So what's more to say about change sets? Change sets are run in order, so in order of declaration. So in that case, it's quite easy because we only have, a master change log that includes a relative master change log that includes these. So the first change set that's going to be executed is the one at line 5. And good morning from Brazil, yet another country. Yay, that's great. I mean, to see so many countries today. And so the first change set will be executed, and if all goes well, if it fails, Liquigraph will stop there. But if it doesn't fail, it will continue and run the second one. So the order of declaration matters. And another thing that is important to know, a change set is uniquely identified by ID and author, so the combination of both. So of course, within the same XML document, so here by XML document, I mean this init domain XML file, I cannot have duplicate IDs, right? Because XML does not allow it. ID has to be unique within the document. However, I could have the same ID somewhere else, let's say in changelog.xml, I could have something like this. So let's say I add a new change set directly here, which is completely fine and completely allowed. I can have the same ID, however, I cannot have the same author because this combination already exists in the init domain. So that's not allowed. So what you would do, you would either change the author or the ID. But you need to make sure that the combination of ID and author is globally, within the set of migrations you have to run, is globally unique. And I know Liquibase, the tools that Liquigraph took inspiration from, is a slightly more flexible in that regard. In our case, because again, it's a hobby project that I maintained over my personal time over the years. I've kept it simple. So yeah. So as a recap, change set runs in its own transaction, which means we cannot mix in a single change set queries with indices, schema, and data. It's either one or the other because Neo4j does not allow mixing them. We can have as many queries as we want. I could have a second query, a third if I want. So in that case, I keep the demo simple. So I'm just have one single query. And they are uniquely identified by ID and by the combination of ID and author. With the extra constraints of XML that an ID within the same document cannot be duplicated. So maybe let's start with this first. Let's start with a single change set first. So if you're not completely familiar with Cypher, I assume most of you are, but if not the case, it's completely okay. This query, what will it do? It will create a node in the graph, right? Because the graph structure is nodes connected by relationships. And so I will create a node with a label called sentence. So a label is a way to group similar nodes. And my node will have, with this JSON-like syntax, will have a single property called text. And the value will be a string with hello monde, which is probably a strange way to say hello world, but we'll come back to that. And all right. So that's nice. Now I understand the migration system. I have a first migration ready, but how do I run it? There are several ways to run it, but for the sake of being the most generic possible, I'm gonna use the CLI. So Liquigraph comes in several flavors. If you're in the Java JVM ecosystem, you can use a Maven plugin. So Maven is a popular build tool. You can use a Spring Boot integration. So Spring Boot is a project in the Spring portfolio. You can use the Java Core APIs because Liquigraph is primarily written in Java. But of course, if you are not on the Java JVM ecosystem, we don't want to exclude you. We want you to use the tool as well. When I say we, it's mostly me, by the way, but And so you can actually use Liquigraph as a CLI. So you can download it directly. So links are in the documentation on liquigraph.org. Or you can install, if you're on macOS, you can do it like this. I believe I already have installed it, so nothing won't happen. Nothing will happen, but we'll see. That's a way to install Liquigraph quite easily. If you're interested in having the same for Windows, there is this Chocolatey project, which is more or less a package manager for Windows as well. I know how to do it, have not taken time yet to do it, so if that's something you're interested in, let me know. I'm happy to work on it, or even help you contribute to it, that's even better. And so it should, yeah, it's already installed, so see, I have Liquigraph 4.0.2, which makes me think, what is the versioning scheme of Liquigraph? So if I go back to the website real quick, if I can see a window somewhere, yep, I can see it. And again, the website is not great, documentation is not great, but that will change soon. There are mainly 3 concurrent versions of Liquigraph, 2, 3, and 4. When I started Liquigraph a bit before Neo4j2 was released, so it was a long time ago. And because Neo4j2 was released before I was able to release the final stable version of Liquigraph, I decided to align the major version of Liquigraph with the major version of Neo4j. Which means that Liquigraph 2 is for Neo4j2, Liquigraph 3 for Neo4j3, Liquigraph 4 for Neo4j4. That being said, Neo4j2, you're probably not using it, and if you do, you should upgrade as fast as you can, because there is no officially supported version for Neo4j2 anymore. The first still supported version is Neo4j 3.5, which is an LTS, a long-term support release. So if you're using Liquigraph 2 or Neo4j2, you should really try to upgrade to Neo4j 3.5 and use Liquigraph 3 instead. Because of security issues, upgrades are not done anymore on that, etc., so security fixes, etc. So really, if you have Neo4j2 still, please try to upgrade as fast as you can. So that's why so in that case, I'm using Neo4j Desktop, as we'll see shortly, and I'm using Neo4j4, and I'm using Liquigraph 4. So you can have also, features relevant to Neo4j4, such as the multi-tenancy, the multi-database stuff. You can have multiple databases per server, etc., etc. So that's how the versioning scheme works. The major versions of Liquigraph are aligned with the major versions of Neo4j, but that's about it. So we don't follow the minor scheme. Like if there is 4.2 something, Liquigraph will still be 4.0 something, unless there is a breaking change, and then we'll bump the minor version as well, but only the major versions are aligned, and we really try to keep a single branch per major version, which can be challenging sometimes, but yeah, just so you know. So in that case, just to make sure, if I run Liquigraph version, I have 4.02, so that's great. And I should be able to see the help. And I see it, that's nice. So, Liquigraph currently is very simple. You have 2 available operations with the command line. It's the same with the Maven plugin, with the Spring Boot integration, with the Java Core APIs. The same set of operation is exposed everywhere. And so let's have a look real quick at what we can do. So changelog, it's a single entry point, as I was mentioning at the beginning of the stream. Changelog is a master changelog location. So in our case, that would be this file, the file at the root of my project, so this Liquigraph demo folder. So just the path to it, basically. You can use ClassPath, but it's not relevant here for the CLI. Database is when you have multiple databases and you want to target the non-default one. I will come back to the dry run output directory a bit later, execution context as well. Then GraphDB URI, so quite important. So you could call it an abstraction leak in a way, because Liquigraph is using the Neo4j JDBC driver. So what is JDBC, you might ask? JDBC is a Java spec, a Java standard, a set of APIs for connecting to relational databases. And you heard me well, I just said relational databases, and Neo4j is not a relational database, it's a graph database. And so why is the choice of using the JDBC driver in the first place, right? Why did Liquigraph do that? And that's mostly an historical artifact here, because Liquigraph started many years ago. Neo4j2 was just about released, and JDBC was the most universal solution to connect to any kind of Neo4j topology. So remember, you might not know actually that the way to connect to Neo4j nowadays is mostly through Neo4j desktop, and then you can use a browser to connect to it. You can also, when you write your own application, as we've seen in my previous live stream with GoGM, or even before that with the Golang real-world session, I would use a Bolt driver. So there would be a driver that connects to a remote instance with the Bolt protocol. So that's the most common way to do nowadays. But before in Neo4j2, for instance, there was no Bolt. There were only HTTP and embedded. And so JDBC allowed me to pick any kind of things. And for Neo4j3, the JDBC including Bolt as well, relying on the Java Bolt driver. So that's why, as an historical artifact, Liquigraph relies on the JDBC driver for connecting. And as a leak, as an abstraction leak, it should be an abstraction. The user shouldn't have to care whether we are using JDBC driver or not. But I was young and naive. I will say I made some mistakes. And the way you have to configure the URLs, I mean, it's not the end of the world, but it might look a bit strange, is to use the JDBC form of the connection URI. So it's not great. It's not a great choice in retrospect, in hindsight, but that's why you need this prefix with JDBC : Neo4j : and then the connection URI you are actually familiar to. So it could be HTTP, HTTPS, Bolt, even the Neo4j scheme nowadays. So it could be JDBC : Neo4j : Neo4j, etc., if you want routing, when you're connecting against the server. So yeah, that's why it looks weird. That's youth mistake. Is that how you say it in English? I would say. And then you can pass the credentials and help and versions that we've already seen. All right, so I have Liquigraph. Great. I need a changelog. So in that case, I need a changelog. So let's point it to my changelog. I have my graph DB URI. You can actually use short options, but I'm gonna keep it simple. So in that case, I have a single instance. I don't need any routing. I'm not in a cluster, so I'm just using the. Except I almost forgot the JDBC stuff. Of course, you have to write the JDBC prefix, otherwise it won't work. See how annoying it is. It's even annoying me. So then username. Oh. My window is a bit misplaced. Yeah, better. Password. So you can write the password directly here. You can also leave it empty and it will ask for the password. And that should be enough. However, before I actually run the migration, there is another mode with Liquigraph called dry run. So if you're not an English speaker like me, dry run, sounds a bit weird. And what it means is actually simulate the execution. Don't execute the migrations, but simulate it just to make sure the connectivity to the database works and that the queries I expect to be run later will be the ones I actually expect, etc., etc. So that's a way to simulate it. And the way to trigger this mode, and it's the same, whether you use the CLI, the Maven plugin, or any other integrations with Liquigraph, is to add this parameter here called dry run output directory. And what it's going to do is, if you give this option, then Liquigraph will say, oh, I'm in dry run mode now. I'm not in the regular run mode. And you need to give a path to a folder, and Liquigraph will dump the Cypher queries of the migrations that are selected for running, but it won't run them. And actually, we will double check. So if I go back to my database here, I should have 0 nodes, and if I run the dry run, I still should have 0 nodes. So let's see what happens. I'm in dry run, so nothing bad should happen. And see, it asks me for the password. Also, it's a very stupid one, I believe. Hopefully, I've not forgotten it. Yes. You can see a bunch of logs. By default, we allow debug logs. By the way, if you think it's a bad idea, you also see some stack traces. That's because of the module system of Java, so it's a bit annoying. I might try to work on it to try to get it a bit less verbose. But anyway, because I use the dry run directory, I use the current directory, you should see a file here, output.cypher. And what's in there? Let's have a look. And if I look at output.cipher, you can see actually it selected the change set with author Biville, ID hello world. There is no execution context. I will come back to that later. And it dumps basically the queries that would be run in a regular run. But again, let's check, but it shouldn't have run anything against the database. So if I rerun my query here, yeah, still 0 nodes. But so far, no exception, nothing, it didn't crash, so it probably means that my connectivity settings are correct. And yeah, so now to just trigger the regular run mode, I just get rid of this parameter here, use the password again, and let's see. So it's, debugging a few things. And let's see. So I could count, but first, if I have a look at my query, what does it do? If I look at init domain, because that's where the fun happens, I create a node with labeled sentence. So I'm just gonna be a bit lazy. I'm gonna, copy that. And so let me maximize. I'm just gonna match it and return it. And if the migration runs successfully, then there should be a result in your Neo4j browser. And so let's see. And yay, there is a node. Hello Monde, so property text hello Monde, so might not be super visible in your screens, but there is a node at least. I can see that. So cool, that's cool. Now let's check. How many nodes should I have in my graph? Well, I just had a query that created one, so I assume there will be one node in my graph, right? And let's have a look. Oh, 4 nodes. What? There are 4 nodes in my graph? What happened? That's very strange. Let's have a look. Let's see why. I expected only 1 node. Is Liquigraph completely broken? So spoiler alert, nope. What happens here is, and that's something I've not talked about yet about change sets, but Liquigraph not only runs the query you want it to run, but it also remembers what change sets it run. And why is that? Well, to understand it a bit better, I'm gonna rerun the same command. And what do you think should happen in that case if I do it? If I rerun the same thing, so it's still the same change set that creates a node with a labeled sentence and a property called text with the value hello monde, what should happen in your opinion? Let's see. So it still runs successfully, that's great. And let's maybe, oh, I deleted it. Okay, it's fine. Let's try to see how many sentences we have here. So should we have 1? Should we have 2? Or more, maybe? We still have only 1. And that's something that's also very important to understand. It's the same thing with Liquibase, by the way, and probably with Neo4j migrations. A change set, by default, runs only once. It's incremental. So if you want to add new changes, you wouldn't change an existing change set. You wouldn't modify it. You would add a new one. So the strategy, so to say, is to pile up changes, to add them up, not changing the existing stuff. Which is why, but how does Liquigraph do that? Well, it needs to remember which ones it has already run, right? Because otherwise, there is no way to know whether it has already run a given change set against a database. And so coming back to Neo4j Desktop, as you see, there is only a single sentence node because the change set has not rerun. Although I asked to rerun the migrations, because there is this weird graph I've not talked about yet, it knows that the change set has already run, and therefore, it won't rerun it. And you can see there is this green node here, which is actually a change set, so the change set itself that run within the changelog at a specific time. And there was this query in a specific order of this change set. So in that case, there is only one query, one change set within the changelog. And that's how Liquigraph remembers that the change set has already run. So that's one very important default, so I emphasis on default, characteristic of a change set. It is incremental. It will run only once against the same database. So of course, if you by accident remove the history graph, as I call it, so this section here with the changelog node, change set node, and query node, if you remove it, then Liquigraph will have no way to remember that it's actually what it has run or not. So it would rerun the queries, and you would end up with duplicated information. So that's a tiny drawback of this approach. Is the history graph is in the same data plane, in the same database as the actual data you need to change. So you must be careful with your migration. For instance, if you have a query in migration that want to delete all the data, you need to make sure to exclude the Liquigraph history graph, because if you run the migration and delete all the data, then Liquigraph will be lost next time it runs. So yeah, that's just a tiny gotcha. But while I'm also talking about change sets, another important characteristics, as you might not see sadly because the resolution is not great, but there is a checksum attribute for every change set. Why? So I told about the incrementality. By default, a change set can only run once. But there is another important default characteristic. That is, by default, a change set is not allowed to change ever. And that's why Liquigraph also stores the checksum. And you know, Liquibase does the same, by the way. So if I try to fix it like this, for instance, say, hey, it's not hello monde, it's like Franglish. What is this? It should be hello world. If I do this, and that's not a good idea, and if the demo gods are with me, it should fail because it is not allowed. You know, it's identified by ID and author, so it will know there is a matching change set in the graph. However, the checksum won't match. I mean, if it doesn't fail, then it's called a bug, and I will be very sorry about it and try to fix it. But here, it should fail, because by default, change sets are immutable. They are incremental, they run only once, they are immutable, they are not allowed to change. The strategy when you use a migration tool is to add up changes. It's not to modify the existing stuff, because it might have already run in some of your environments. And so let's try again. So here you see I've cheated. I say, okay, I fixed my query because it was not right. But I should see a big error. Yeah, so maybe not the best way to report it, but you can see the change set with ID hello world with author Biville has conflicted checksum. What's persisted in the database is this. So the one it registered, as we've seen, is in a Neo4j browser. There is this 6777 blah, blah, blah. But on the XML side of things, on the file system, it computed the checksum, and it's not the same. So that's why it fails, and it refuses and stops there. But again, that happens change set by change set. If it is the 5th change set that is like this, the 4 change sets will have run successfully, but not this one. So instead of fixing the existing query, you create a new change set for that. And I should still have it somewhere. Let's see, somewhere over the rainbow. Here we go. And that's my initial example in the documentation. That's the first is the first migration with a tiny mistake. And instead of trying to fix the mistake directly in the existing change set, I will, match the existing sentence and update the property to have it say hello world properly. And maybe let's add the exclamation point, because it's a happy new year. So now I could do the, oh, by the way, let me, before doing that, an interesting thing maybe, let's rerun the dry run stuff. So in that case, you will see that the output cipher will say there is nothing, because I'm back to the regular query. I've reverted the change. nothing to persist, nothing to do, which is completely normal. That's what we've learned already, is that a change set is persisted into the graph, so it knows it has already run, therefore it won't run again. That's great. So let's go back, put it here, run the dry run, because it's a good practice, it's a good idea in general to run before actually running. And so in this case, we should see in the output cipher only the second change set. Again, same consequence from the same principle. The first change set has already been run, so Liquigraph knows that, and the dry run will tell you, hey, I will only run this, which is, the update, basically, the property update. So that's exactly what I expected. Therefore, I'm good to go with the actual execution. And let's do it. And so I expect to see my sentence node in Neo4j desktop, within the Neo4j browser. I expected to see with the new property value. So we'll see. And here we go. If I, let's say, select my sentence again, I can see, maybe you cannot see because it's a bit small, but it's hello world now, so it's been fixed. So that's great. I've managed to actually fix without cheating, without changing the existing change set, without changing the existing migration, because that's not the way to do it. There are technical ways to do exactly that, but that would be a bit cheating. So instead, and if I refresh the whole graph, oh, the graph has changed a little bit. So there is still a single sentence with an updated text property with hello world. However, you can see there is a new change set in the block. So there is this one, which is new, which corresponds to the new change set with the associated query. Or queries, and it could be there is an order property for within the changelog between change sets, but also for each query in a change set, there is an order property on the relationship. So you can see the history graph has changed as well, which completely makes sense. So that's it for the basic introduction. So what we've learned so far, if I recap, so we learned there are several ways to execute Liquigraph. I just showed the CLI here because it's the most universal way to use Liquigraph if you're on the Java JVM ecosystem, and you will see that in liquigraph.org. You can use the Spring Boot integration, the Maven plugin, the Java Core API, even if you want, although it's probably not recommended. In terms of version, Liquigraph 4 is for Neo4j 4, Liquigraph 3 is for Neo4j 3, Liquigraph 2 is for Neo4j 2, and you should probably not use Neo4j 2 because there are no officially maintained version for Neo4j 2. The first officially maintained version is Neo4j 3.5. So you should not use Liquigraph 2 because you should not use Neo4j 2. If you're still using it, try to upgrade. And once you know so in that case, I'm using Neo4j 4.2. something, 4.2.2 or 4.2.1, I don't remember. So I'm using Liquigraph 4, and then I can run the queries. We've learned that migrations by default are run only once. They are incremental. They cannot change. They are immutable by default as well. And Liquigraph stores the history graph at the same location as the query you run, basically. So that's about it for the basic introduction. I can show more advanced concepts. One of them, which can be quite useful in complex environments, and it also exists in Liquibase, by the way, is called a precondition. So let's see about that. A precondition is quite useful when you have slight variations in the different databases. Let's say you have a database in staging, you have a database in production, you have a database, in integration, you have a local database, etc., etc. And it can happen sometimes, especially when you start using a migration tool, and there was no migration tool before, there was no formal process to evolve your databases. It can happen, there are slight variations, but you would still want to use the same migration for that, despite the slight variation. So preconditions are a great way to try to, remove the disparities between the environments. I've used that a few times with Liquibase. So I don't know. Let's say let's say I am in a production environment here, and for some reason there was an urgent bug in production, and I had to create a second sentence, just for a temporary fix. So I will add a new sentence, and I don't know, I will have it a text. I don't know, we needed something in Turkish, for instance. Yeah, let's say hello to everyone in Turkish. Okay. For some reason, let's imagine we have something like this that only happens in one specific instance. So I've added a node. So if I refresh the whole graph, I should see 2 sentences now. However, when I want to run my next release, so I will ship new code, but I will also, refresh the database structures. So I want to make sure this temporary fix is gone. So what I can do instead and let's say I have other databases which do not have this. Maybe it's not the best example, actually. I'm trying to think about it. But let's go with the flow. It's a bit of a fictional, a bit of a dummy example, but because I could just run a remove query, and that would work in any case, because either it would not match anything and then not remove anything. But just for the sake of it, it's probably not the best example of the world, but we'll go with it. Let's say Turkish sentence removal. The better descriptive UID is the better for everyone. And I will add a precondition first. Or maybe, you know what? Translation, let's say. I don't know. I'm just going to change my mind. I'm just going to revise a little bit, so bear with me. It's probably not the best example. And so we have preconditions in Liquigraph and in Liquibase as well. And as the name may suggest, a precondition is something that is checked first before running a specific migration. So I have this node inside the change set, and then I have several ways. I can go there is Boolean logic, so you can have or, you could have and, etc., etc. In that case, I'm going to have a single precondition query, but I could combine several ones. You would have and or and whatever you need. So in that case, we just have and or. We don't have not, by the way, because you can just flip the result of your query instead of using not. So it's not super needed. And so I have a precondition query. And currently, the constraint on the Liquigraph side is that the column, there should be a single column, so to say. So think of the table view in the Neo4j browser, for instance. You should have a single column, and it should be called result. So for instance, I could count maybe. So that's a bit of a, I'm just going to go back with the removal example here. That's a bit dummy, of course, because I actually don't need any precondition to remove stuff, because if the stuff is not there, the removal won't do anything. But again, bear with me. And everything that is not hello monde, so I believe that's the correct syntax, we'll see. So for now, I'm just going to real quick check in the browser that I'm not writing a wrong query. So what happened if I do? I expect this query to return me the Turkish sentence I've just added. And yeah, of course, it's hello world now because my second migration has run. So yeah, oops, wrong, and it went with an upper M anyway. So if I run this again, okay, I have a single node. Okay, that's exactly what I expect. And so in that case, I'm just gonna count. I'm just gonna count those nodes, but again, return count equal, larger than 0 as result, because again, the column must be named result. So in that case, I'm counting all the sentences that I'm not expecting, because my database in every environment should have a single sentence. That's a very strong business requirement. So as you see, it's just a query within a precondition block, but it could be, and or. I could have an and here and a second query. I could even combine, I could have an or and, so I would have a second query that goes in there, etc., etc. So you can do complex Boolean logic in XML, which is something everyone dreams of doing, right? But joking aside, so this precondition will run first, but then there is something extra you need to tell Liquigraph is what happens if this precondition if this condition is not met, if this condition is not respected. In that case, you have basically three options. You can ignore it, you can ignore and go and so you can ignore the whole migration and continue to the next one. You can fail, like that's a hard requirement, and if something is wrong there, you want it to fail, so you will at least you can identify which environments have discrepancies. Or you can simulate the fact that the change set has been run, but it won't actually run it. So maybe, I'm gonna first I'm gonna do the fail stuff. So yeah, if the condition is not met, then the change set, so the transaction associated with it will fail, will roll back. And so Liquigraph will stop there. However, in our case, if I do something like this, I believe the result should be true because there is more than 0 nodes that are not. Oh, it's still hello world? My bad. So let me fix that and query it here. So the result is true, so it should not fail. So if I try this and I rerun, so this time I'm just gonna do, I'm not gonna do the dry run. You should probably do it, but for the sake of time, because we have only a few minutes left, I'm just gonna go ahead. So if the condition is not met, it will fail. But as we've seen, the condition will be met, so it should not fail, and it should just, oops, what did I miss? The demo gods are not with me today. The content of elements. Oh, yes, I know why, and that's very annoying. Welcome to XML. I have this character here, larger than. And yeah, that's the fun. So let me check real quick. I think it should be C data, something like that. So you have to protect, yeah, that's the fun part. When you start to use complex, reserved characters in XML, you need to. So let me check real quick. Actually, there is a valid example in the documentation. So let me, I don't remember the C data placeholders. That's the joy of XML. So because it thinks the larger than is actually part of a node tag, but it's not. So if we look, we have example down below where we sometimes need to keep the C data. So, okay, here it goes. So that's not the nicest thing about XML, but usually it works. And the C data must end with a double bracket, I believe. And yeah, so it's a weird syntax, but that way everything between those two weird placeholder here won't be interpreted as XML. So this larger than won't be interpreted as such. So yeah, that's why I had this ugly XML parsing exception here. Again, reporting could probably be a bit improved, but let's rerun this. Now that I have protected everything, yeah. And now it runs fine. And oh yeah, except I did one thing that was a bit stupid. So let me something you should never do is delete everything, but I'm gonna delete everything and detach delete, of course, because there are relationships. Because yeah, I went a bit too quickly. What I want to do in that case is basically to remove all the extra sentence. I know the precondition is a bit far-fetched in that example, but and just to be delete n. So we're going to delete everything that is not the sentence with hello world. So because I've deleted everything in the database, so I'm back to 0 nodes. It's basically going to rerun all the migrations. Except, yeah, fun bit. Let me go back to the state where first. So let me do that real quick. So back to a single sentence with hello world. If I remove this, refresh the graph. So we don't have currently another sentence, so I'm just going to recreate one real quick because we don't have much time left. And let's say again in Turkish, because why not? Herkese merhaba. Here we go. And if I rerun my query, yay, cool. So it's there. So now I'm gonna put it back. So if I don't find any extra sentences, it should fail. But in that case, I have an extra sentence. And oh, okay, still no luck. It consists of well formed. So what did I miss? Oh yeah, same problem with the query, of course, because I'm using this different operator, which is lower than and more than. So again, XML for the win. And let's try. Let's rerun this. And now it should stop annoying us. Yeah, here we go. And so I had a sentence without the hello world text, but if I refresh it now, boom, it's gone. And of course, if I check everything, if I check the whole graph, the whole history graph should have an extra change set. So let's rerun this, select auto node. Oops, cannot type today. Yeah, you can see now that the history graph has a third change set with the text, with the query, the change sets, and the change log. So that's a way to do it. Otherwise, you could change the policy. So mark executed, it would mark the migration as run, even though it hasn't run, or you could continue, just ignore the migration completely. And I will stop there. There is an extra thing that I have not mentioned, which is post condition. So we can have a look at the documentation example real quick together. Post condition is more or less, the little cousin of precondition, and that's something that does not exist in Liquibase, by the way. Is let's say you need to run a query on a huge volume of data, and you don't want to do it, at once, because you could run out of memory. So in that example, and so we have, because we use relationship patterns, we also have to protect it with C data. We deleted 10 by 10, and so we run the query and then check the post condition. And once the post condition is not met anymore, then it's basically like a do-while loop in programming terms. So it will run the query as long as the post condition is true. So that way, in that case, you see the limit 10 in the query, it will run a deletion of relationships 10 by 10. So that's a way to have some kind of batch migration. So, and still run within the single transaction for the change set, by the way. So it's a batch, it's a single transaction, but with a batched execution. So that way, I think you shouldn't run into any memory issues. And that's about it about Liquigraph. But as I told you at the beginning of this session, I had a small announcement to make. Even two, because I already mentioned it, but I'm actually working, I can show a sneak peek of the new documentation because this one has not aged quite well. So I'm currently working on this documentation, which hopefully should be much clearer with the important information first. So it's still not complete, right? I only have the CLI at the moment, don't have Maven plugin. I have some quick start guides that I reviewed, that I revisited. So it's in progress, it's not complete yet. And then the reference docs is not completely done yet, with more important information about how to connect to a cluster, etc., etc. So that's something I'm working on currently on my own time when I have some time. So it's a work in progress. Hopefully it looks much nicer, and I'm very interested in having your feedback on that, and even your help if you want to, work on this with me. So that's the first announcement. So that's a new doc, still not there yet. It will be released under liquigraph.org when it's complete or complete enough. And the second announcement is that Liquigraph will soon, for some definition of soon, I don't want to commit to a deadline, will be replaced in the midterm, hopefully soon enough, by a Liquibase plugin for Neo4j, and I'm very happy to announce that. Why is it a good thing? So first, the plan is to have a smooth migration between Liquigraph and Liquibase. So even if you start using Liquigraph today, and you should, you will be able to run Liquigraph, the Liquigraph plugin afterwards transparently, with the current exception of post conditions. That's the only thing that we don't have a replacement for at the moment. So we might try to think of strategies around that, but that might be the only feature of Liquigraph that won't be transparently supported by the future Liquibase plugin for Neo4j. And why is it a good thing? So not only you will be able to migrate smoothly from Liquigraph to Liquibase, but by doing so, once the Neo4j plugin is ready, as we've seen today, Liquigraph only offers dry run and run. And with Liquibase, with the Liquibase plugin, you will benefit from all the existing, almost all the existing operation from Liquibase. So you will get access to a myriad of features that I have never had time to implement with Liquigraph. So that's a work in progress. I have a review this week to try to merge the final bits of the first milestone. So the first milestone will be, the basic works. The second milestone should be soon in the month, next month, hopefully this quarter, about the Liquigraph migration path, because that's really important to me, that Liquigraph users can upgrade smoothly. So that will be the next thing I will tackle. But even today, it's not published yet, so you cannot use it yet. But I tested on my branch, and it's quite promising. You already have access to many more operations that Liquigraph offers today, so it will be much more flexible, and you will benefit from the battle-tested code base of Liquibase. Most of the hard bits are implemented by Liquibase. I just did some Neo4j specific bits, basically. And by the way, I really want to thank Nathan Voxland, who really helped me during this implementation. So that's really something that's been he's been super helpful. He's the founder of Liquibase. He's been working on this for a long time, much longer than me. So his advice was really, really precious. And also Robert Reeves, the CTO of Liquibase, who, thanks to him, we started working, discussing about this a few months back, and started working on this recently. So thanks to both of them, we have soon I will be able to share the Neo4j plugin for Liquibase, and probably will be a live stream. But again, that should not prevent you from using Liquigraph today. I'm working hard on making sure that the documentation will be nicer, clearer, and yeah. So please try to use it, raise an issue if there is a problem. I will try to fix it. And soon enough, I will be able to demo the Liquibase plugin, which will be even nicer, and you will be able to migrate from one to the other. So I would thank everyone for staying with me. I exceeded the hour a little bit, my bad. And so yeah, have a good day, have a good afternoon, good evening, good night. Thank you for joining today, and we will resume hopefully the GoGM live stream soon. If you're interested in Golang and the usage of this object graph mapping library from our community member Eric Solander, CTO of Mindstand. And yeah, we'll keep in touch. So thank you, thanks a lot, and I will see you around. Bye-bye.